All right, so we are on to the second part of our video here. Topic 4 is all about rewriting formulas. Remember that rewriting formulas means that you are solving for another variable and writing an equation that is equivalent to the original formula. So to solve a variable, you work through the same steps you would as to solve an equation, right? When we solve equations, we solve for x, we think about PEMDAS and we work in reverse. It is the exact same as we are solving for formulas. So our first example says solve the distance formula for the rate. Now, when we look at the distance formula, d equals RT. We know that the rate is r, so we are trying to isolate r. How do we solve for r? We simply divide by t. That isolates r, and we are left with r equals d over t. R is by itself, so we are finished. Now, one important rule is to always write the single variable first. Is it necessary? No, but it avoids a lot of mistakes in the long run. Okay. Second example, we have solve the formula for the sum of all interior angles of a polygon for n. If you remember this formula from geometry, S is equal to 180 times n minus 2. We're going to look at two different ways to do this. Starting with the first method, rewrite our formula. So our goal is to solve for n. Let's think about what we need to do to isolate n. We can see that we have 180 being distributed into n minus 1. So the first thing we need to do is get rid of 180. We're going to divide both sides by 180. Leaves us with s over 180 equal to n minus 1. And you can see one more step, get rid of the minus 1 by adding 1 to both sides. This gives us n equal to s over 180 plus 1. And there's our answer. Pretty simple. Second method is to simplify first. So instead of getting rid of the 180, we are going to go ahead and distribute the 180 into the equation. That gives us s equals 180n minus 180. Solving for n, you can see n is now attached to 180, so we can't get rid of it yet. Let's go ahead and add 180 to both sides. And we have s plus 180 equal to 180n. Solving for n, we can now get rid of 180, so we are going to divide both sides by 180. This gives us, now remember when you have a fraction, you have to divide both items in the numerator by the denominator. So we can split that off into s over 180 plus 180 divided by 180 plus 1 equals n. Rewrite it, single variable on the left side, always first. N equals s over 180 plus 1. And you can see that they are the exact same equation, just two different methods to solve. Finally, example 3 has two variables. We have x and y in the equation, however, we are solving for x. So we have 7x minus 4xy equal to 5. We are solving for x. Anytime you see two of the same variables, you must factor it out. Do not try to divide, factor it out. Okay, so how do we factor it out? We simply take it out of the equation. If you see 7x, 4x, they share the x, take it out, right? It's like undistributing the x. So we have x times what's left over, 7 minus 4y equal to 5. Now you can see it becomes a simple one-step problem. What do we need to get rid of in order to isolate x? We're going to divide by 7 minus 4y, all in one step, because it is a quantity being multiplied to x. And we have isolated x. X is equal to 5 divided by 7 minus 4y. Topic 5 is all about graphing linear inequalities. Now, if you guys remember graphing inequalities, this is something you learned in pre-algebra. We have two simple examples here. We have x is less than or equal to 4, x is greater than -2. All we are doing is graphing. So go ahead and draw a number line. And I'm going to label it with my 0 in the center. I know 4 is over to the right. So how do we graph it? If you remember, when you have a greater than or equal to or less than or equal to, you always use a closed circle on that number. If you have less than or greater than, we use an open number because that is not considered to be part of the solution. So first example, x is less than or equal to 4. We have that equal. I'm going to go ahead and close that circle. Anything less than 4 is part of the solution, so I'm just going to shade my number line over here. And these are all valid answers, right? That means I can substitute anything that is less than 4 and it would give me a true statement. On the other side, x is greater than -2. Draw our number line, label it. Here's 0, here's -2. I know that -2 is not included. It is not part of the answer, so I'm going to use an open circle and shade everything to the right because I'm looking at everything greater than -2. Now, what does it mean when I say that the answer is not included? Well, if I use -2 in this inequality, -2 is not greater than -2. That is a false statement. However, anything greater than -2, for example, -1.5, right? Is -1.5 greater than -2? Yes, so that is a true statement. When we have combined statements, okay, and means that both conditions are true. This is the overlap from the two given conditions. Or means that all the values in the solution make at least one condition true. So you have to be cautious when you look at the graphs and your inequality statements. Let's go ahead and look at the first one here. We have -3 less than x less than or equal to 2. Going to draw my number line. I have -3 on the left, 0 in the middle, 2 over on the right. Now, because this is a combined statement, a joint statement, I'm going to graph these separately on top of my number line first so that I can see what that's going to look like. Starting with -3 is less than x, I know I can rewrite that as x is greater than -3 just to help us out a little bit. Open circle at -3, arrow towards the right. Anything greater than -3 is a valid answer. Then we have, let's do a different color here. X is less than or equal to -2, close circle at +2, sorry. And anything less than 2 is a valid statement. Well, you can see what happens here is that we have an overlap. That overlap is the solution to an AND problem. It means that anything in that overlap is going to be an answer to our inequality. So I'm going to go ahead and combine these two down at the bottom on my number line. Open circle at -3, close circle at 2, and everything in between is a valid response. For example, I can come back and substitute 0, right? 0 is in the middle. Well, is -3 less than 0? Yes. Is 0 less than or equal to 2? Yes. So that makes our statement true. Then we have x is less than -2 or x is greater than 1. Here's my number line. -2 on the left, 0, 1. Okay, again, I'm going to use two different colors because I have two different problems. I have x is less than -2, open circle at -2, everything to the left. And then we have x is greater than or equal to 1, close circle at 1, everything to the right. Now, there's no overlap, but that's okay because it says or. Okay, that means that any number that works for either of these inequalities makes either inequality true, so it works as your solution. For example, less than -2, I can pick -3. Was -3 less than -2? Yes. Is it greater than or equal to 1? No, but it doesn't have to be because it can be true for either statement. Down at the bottom, our third example, we have x is less than -2 and x is greater than or equal to 1. Starting with my number line, -2, 0, 1. Now, this is an and statement, so we need to be careful when we're graphing, okay? Starting with x is less than -2, going to place an open circle, everything to the left, and then we have x is greater than or equal to 1, close circle, and everything to the right. Okay, remember that for an and statement, we should have some kind of overlap. This does not have any overlap. And because we need to satisfy both inequalities at the same time, this only leads us to a no solution because there is nothing that will make both of these statements true at the same time. And finally, x is greater than -2 or x is less than or equal to 1. So here's my number line, -2, 0, 1. We're going to start by graphing x is greater than -2, open circle, everything to the right. Then we have closed circle at 1, everything to the left. Well, you might see that there is an overlap, right? But because our statement is or, that overlap does not matter. What we are seeing here is that everything on our number line is going to make our answer true. So any number, how can I word this? Any number can satisfy either inequality. So this tells me that all real numbers would be our solution. Any number would make these statements true. Now, how can we shorten all real numbers? I don't know if you guys have seen this, but there is a symbol for all real numbers. It's like the paragraph symbol in Microsoft Word whenever you're working on a document and you see the paragraph symbol, except it's an R. That is how we define all real numbers. All right, topic 6